resultant, the sum of the forces is what? Negative 100 plus 200 minus 300. And if you wanted, you could have treated these two as a couple, right? We have 300 down, 200 up. You really only have 100 going down. And this is in the I direction, and this is all in the J direction. So the force came out to be negative 100I minus 100J. And what's the units? Pounds. And what's another way we could express a force? What is this being expressed as, Paul? How am I expressing the force here?
Okay, vector.
Vector form. What's another way, Karen, we could express a force?
Magnitude and unit vector.
Right, and?
Magnitude and direction angle.
Direction angle. So let me do that one. So the magnitude of this force would be 100 squared plus 100 squared under the radical, and I think it comes out to be 141.1 pounds. And let's do theta x is equal to the inverse cosine of negative 100 over 144. And theta y would be equal to the inverse cosine of the same, negative 100 over 141.1.
It's a 141.4.
4, thank you. No, that's good. Okay, and what does the theta angle turn out to be? Jill, what did you get?
I haven't gotten anything yet.
You got 135. 135.0 degrees and 135.0 degrees. So I found the resultant force. So point with your hand which way the force is going. It's going down to the left, right? It has a negative 100 and a negative 100. So this is showing me the resultant force. And now we're looking at the resultant moment. So some of the moments, what do I want to find the moments about? What point?
C.
So Armando?
B.
Right, because that's what they asked us for, right? So what's that? 100 times 10 positive, 200 times 1220. Positive, and then 300 times 14 negative, and what does it come out to be? 800. 800 inch pound, and is it positive? Positive. So on these equivalent system problems, I always have to calculate the resultant force and the resultant moment. And then the last thing I have to do, because this is a force equivalent system force moment problem, I need to draw the item. So I have a bracket. I have 8 inches here. I have 12 inches here. I have 10 inches here. This is point B. I'll just put the points on A, C, E, and now what do I have to draw? JJ. In order for this drawing up here to be equivalent to this, what do I need to draw on here? So I have to draw the force and the moment.
Yeah.
So what's the resultant force?
141 pounds.
141. And which way did everybody say it's going? Down to the right. So here's my 141.4 pounds. And we should put an angle, right? If it's 135, what's this angle? 45 degrees. And then what else do I have to put on there? JJ?
The moment.
The moment, and we got a positive, right? So we do draw a positive moment as well, and we say 800 inch pound.
you always put the resultant force defined off the point of interest?
You always put the resultant force at the point in question. So if we had this bracket built, if we made it out of popsicle sticks, and we applied 100 pounds to the left, 300 to the bottom, down, and 200 up, we would find this bracket is being pulled down to the left and it's spinning in the positive direction. That's what we would find. Does everybody get that? If you can picture, take a hot glue gun, glue 2 popsicle sticks together, put the top end, point A, put 100 pounds, D, 300 pounds, E, 200 pounds. You probably would want to put a little less weight than that on a popsicle stick. And you would find the net effect is causing it to be pulled down to the left and spinning 800 positive. Does everybody agree? So this is a force moment equivalent system. How about if they went further on and said, we don't want to just know what the force moment equivalent system is, but we want to know the equivalent force location system. So I'm going to draw the bracket again. Eight inches, 12 inches, 10 inches, B, A, E. So Haley,
Where did you get that 45 degree angle on?
oh, because my theta x is 135 and my theta y is 135. So that means from here to here is 135, that's theta y. And here's my 135 theta x. Whenever you have a question, please ask it, because Haley just asked that, but probably 5 of you had the same question. So here they wanted an equivalent system that was a force moment, and you drew the force and moment at that point. But now they only want one force. They want an equivalent system that's one force at a certain distance. So what should we do? Jill? Right. So we know the perpendicular distance is equal to the absolute value of the moment divided by the force. The moment's 800. The force is 141.4. And what's the perpendicular distance come out to be? 5.7 inches. So draw the bracket if you haven't drawn it yet. This is the place that people make mistakes, the drawing of this. So in lecture, I don't know how many people understand it, but when we get to the quiz, half students in statics get it wrong. When we get to the exam, a quarter are still getting it wrong. So we're going to get it right now. Everybody draw the bracket. I drew the bracket. Jill just told me that it's at a distance of 5.7. If it's a force location problem, you have to draw the force at the location. So how are you going to draw 141.4 in the right direction with a perpendicular distance of 5.7? You know the direction of the force, and you have to place it off that bracket to create that same moment. And talk to the person next to you. You guys decide together.